In this video, we're going to take a look at expanding triple brackets. So this is a topic which kind of follows on from expanding double brackets in the sense that we're just going to expand an extra bracket. So there's a couple of examples that we're going to work through here together, and then there's a couple of examples, or a couple of problems for you to have a go at. So let's work through these two examples here together. Now the question will typically say expand and simplify, and then you're given a set of brackets. So what we've got here is three brackets that are being multiplied together. Now remember, with multiplication, the order of multiplication doesn't matter. So it doesn't matter whether I expand x plus 1 and x plus 2 first, or whether I do x plus 2 and then x plus 3, or x plus 1 and x plus 3. It honestly doesn't matter. Now I typically like to work left to right. However, sometimes you might find it easier to multiply certain brackets together first and then multiply by the last bracket. So like we said, all we do here is we start by multiplying two brackets. So what I'm going to do is I'm going to multiply x plus 1 and x plus 2 together, and then I'm going to multiply that result by x plus 3. Okay, so starting with x plus 1 times x plus 2, let's see what we get here, expanding this using FOIL. So using FOIL here, x times x, that gives me x squared. X times 2 gives me 2x, so we get plus 2x. 1 times x gives me x, or just 1x. And then finally 1 times 2 gives me 2. So if we collect like terms here, we get x squared. 2x plus x gives me 3x. And then finally we've got the plus 2 here. Okay, so we get x squared plus 3x plus 2. And what I need to do now is I need to take this quadratic here and multiply it by the last term here. So we take this now. We take x squared plus 3x plus 2 and multiply this by x plus 3. Okay. Now what we do here is we take each term in this quadratic. So I'm going to take the x squared and we times it by x, and then we times it by 3. Then we move along to the next term. So we've got 3x, we times that by x, times that by 3, and then do the same with the 2. So what I'll do is I'll do this in different pen colours just to make it clear for the first one what we're actually doing. So like I said, we take the x squared, times that by x. So x squared times by x, that would give me x cubed. And then x squared times by 3, that would give me 3x squared. Okay. So that's the first term here done. So we can give that a tick. Now we'll do it's in a different pen colour here. Let's do this in green. Moving on to the 3x then, I do 3x times by x. So that would give me 3x squared plus 3x squared. And then we do 3x times 3 here. So that will give me 9x. Okay. And again, we've done the two terms there multiplied by 3x. So we know we're done there. Okay, so we'll give that a tick. And then moving on to the last pen colour here, just to highlight this, let's do this in orange. We move on to the 2. And again, we do 2 times x. So that would give me plus 2x. And then finally 2 times positive 3, which would give me plus 6 there. Okay. Now before we collect like terms here, let's just double check everything. So x squared times by x gives me x cubed. Perfect. X squared times by 3 gives me 3x squared. Good. 3x times by x gives me another 3x squared. 3x times by 3 gives me 9x. Good. 2 times x gives me 2x, and then 2 times 3 gives me 6. Perfect. So all we need to do now, as the question states, is simplify. So going back to our original pen colour here, I've got x cubed here, and there's no other x cubed term, so we're just simply going to get x cubed. So we get x cubed. We've got 3x squared plus another 3x squared, so that would give me 6x squared. We've got 9x plus 2x, that's going to give me 11x. And then finally, we've got the plus 6 here at the very end. And there we have it. So we've expanded these triple brackets here, simplified, and this is what we've got. So that's the solution to the first example. If we take a look at the next example here, again, there's actually only two brackets written down here. I've got x plus 2 squared and x minus 3, but in reality, we actually have three brackets here. The only reason why we only have two is because we're using index notation. So if we move this squared term here and just write that as a product of two brackets, we've got x plus 2 times x plus 2 times x minus 3 there. Okay. And again, all we need to do now is multiply two of the brackets and then multiply by the remaining bracket. Again, I'm just going to work left to right here, but it doesn't matter which two you pick to multiply first. So I'm going to multiply these two together first. So we do x plus 2 times x plus 2 here. Okay. Again, we're just expanding using FOIL or whichever method you're confident with. So I'm going to get x times x giving me x squared. X times 2 gives me 2x. 2 times x gives me another 2x. And then finally 2 times 2 gives me 4 there. Okay. Now you don't have to write down this line of working here that I'm doing. You can just skip straight away to x squared plus 4x plus 4 if you can see that. But just to make it clear, this is what we're getting here. So x squared plus 4x plus 4. Okay. Now again, what we want to do here is multiply this quadratic now by the remaining bracket, which is this bracket here, x minus 3. So we'll take that up here. We've got x squared plus 4x plus 4, and then we multiply this by x minus 3. Okay, and again what we'll do is we'll actually do it just for this final example here in different pen colours, just to make it clear again. So we take each term and multiply it by what's in the bracket. So we've got x squared, we times that by x, so that's going to give me x cubed. We then take x squared and we multiply that by minus 3. So that's going to give me minus 3x squared. So that's the first part done. Let's change pen colour, do it in green now. We've got the 4x, we times that by x, so that's going to give me 4x squared. So 4x squared. We then take the 4x and multiply that by minus 3. So that gives me minus 12x. Okay. And then finally, so we do this in a different pen colour again. Take the 4, multiply that by x, that gives me 4x. And then finally, 4 times minus 3 gives me minus 12. Okay. So all we need to do now, like the question says again, is just simplify. So we go back to our original pen colour here. We've just got 1x cubed. We can't do anything with that, so we just write that down, x cubed. We've now got minus 3x squared plus 4x squared, which is the same as 4x squared minus 3x squared. So we just simply get x squared there. Okay. We've got minus 12x plus 4x, or in other words, 4x minus 12x, giving me minus 8x. And then finally, we've got the minus 12 here at the very end. And there we have it. So that's our solution to expanding these three brackets here. So that's a couple of examples that we worked through. Now it's your turn. So like always, pause the video now, have a quick go at these two examples, and then we'll take a look at what you should have got. So hopefully you got an okay with these two examples or these two problems. Let's take a look at what you should have got now. So the first one here is just, again, expand and simplify, and then we're given three brackets. So again, it doesn't matter which two we pick, but I usually just work left to right. So I pick the first two brackets. So x minus 1 times x plus 2 there. Okay. So here, again, I'm just going to expand this using FOIL. So I'm going to get x squared. X times 2, that gives me plus 2x. My brain froze for a moment. Minus 1 times x gives me minus x. And then finally, minus 1 times 2 gives me minus 2. So if we just collect like terms here, we get x squared. 2x minus x would just give me plus x. And then we've got minus 2. So we take this quadratic here and multiply by the last bracket, this x minus 3. So we've got x squared plus x minus 2. And then we times it by x minus 3. Now for this one, I won't use different pen colours to highlight that. But if you do find that easier to use, say, different pen colours, then do feel free to do that. It is a good thing to do if you find it easier. So going term by term here, we've got x squared and we times that by x. That would give me x cubed. X squared times minus 3 would give me minus 3x squared. We've then got x times x. That would give me plus x squared. We've got x times minus 3, which would give me minus 3x. And then finally, minus 2 times x would give me minus 2x. And then minus 2 times minus 3, so just be very careful with your signs here. This will give us plus 6. Now, before we simplify this, let's just double check everything. So x squared times x, x cubed. X squared times minus 3, minus 3x squared, good. X times x, x squared. And then x times minus 3, minus 3x, yep. And then finally, minus 2 times x, minus 2x, minus 2 times minus 3, plus 6. Everything looks good. So all we need to do now is collect like terms. So working through this here, we've got x cubed no other x cubed, so that's what we're going to get here. So x cubed. We've got minus 3x squared plus x squared, so that's going to give me minus 2x squared. We've got minus 3x minus 2x, that's going to give me minus 5x. And then finally we've got the plus 6 here, so plus 6. Okay. And then if we take a look at this final problem here, we're asked to expand and simplify y minus 4 cubed. So again, there's technically only one bracket written here, but it is used in index notation. So this bracket here is cubed. So what we do is we write that as a product as y minus 4 times y minus 4 times y minus 4. That's what the problem is actually giving us there. Okay, so whenever you see index notation being used, get rid of the index notation and write out the correct number of brackets. So all I need to do here now is expand two of the brackets and then multiply that quadratic by the final bracket. And obviously, with all the brackets being the same here, it doesn't matter which two you pick. So I've got y minus 4 times y minus 4. Okay, so multiplying here using FOIL again, I'm going to get y squared. So we get y squared. I get minus 4y, so minus 4y, minus another 4y. And then finally, minus 4 times minus 4, that would give me positive 16. Okay, so collecting like terms here, we get y squared minus 8y plus 16. So we take this quadratic here and we multiply by the last bracket, which is y minus 4. So we've got y squared minus 8y plus 16. And then we times that by y minus 4. Again here, I won't use a different pen color as we work through this, but feel free to do that if you find that easier. So what I've got then is y squared times y. So that's going to give me y cubed. Y cubed there. Y squared times minus 4 would give me minus 4y squared. Minus 4y squared. We've got minus 8y times y, so that would give me minus 8y squared. Minus 8y times minus 4. So be careful again with signs here. That would give me positive 32y. So plus 32y. So minus 8y squared plus 32y. And then we move on to the 16 here. So 16 times y would give me plus 16y. And then finally 16 times minus 4. That will give me minus 64 there. So minus 64. Okay. So all we need to do now, like we've done for the previous three examples or problems here, is just collect like terms. So we're running out of room a little bit, but we should have just about enough room. So I've just got y cubed here. So we get y cubed. I've got minus 4y squared minus 8y squared. So simplifying that, that would give me minus 12y squared. Okay. I've got 32y plus 16y, so that's going to give me 48y. And then finally, we've got minus 64 here at the very end. So minus 64 there. Okay. And there we have it. So that's our solution to the final problem. So that brings us to the end of this video on expanding triple brackets. In the next video, we're going to take a look at some slightly more complicated examples where we might have, say, for example, 2y minus 4. So it's not just going to be a y cubed. We might have 2y cubed. So the coefficient in front of the y cubed or the x cubed is greater than 1. And some questions in context. So for example, we might have, say, a cube or a cuboid, and we're taking a look at the dimensions to work out, for example, the volume with algebraic expressions. Thanks for watching.